Hey everyone, welcome back to the NumPy playlist. In the last couple of videos, we have talked a lot about NumPy, right? We have seen how to create NumPy arrays, how to slice, dice them, how to index them, how to even smartly, filter out elements from our NumPy array. But what is the real power of NumPy? Why are we even bothering about NumPy? The real power is that it is fast, efficient, especially for mathematical operations on huge data sets. So today, in this video, we are going to see how we can perform math operation on our arrays. So let's say we have two arrays, array 1 and array 2. Couple of things to note here. The array 1 is a one-dimensional array. So is array 2. Array 1 has 4 elements. So does array 2. Now let's say I want to do a element-wise addition. Which simply means I want to add each item or each element of array 1 with a corresponding item of array 2. So for that, we have the plus operator. We have to run this first, and this is what we are getting, right? So 10 is added to 1, 20 is added to 2, we are getting 22, and so on. If we did the same thing for a list, what will happen? So let's say I have this list. Let's call it L1. And another list I have L2. And when we do L1 plus L2, it will basically concatenate the two lists, right? Not do an element-wise addition. So that is how this plus operator works differently for NumPy arrays versus list data type. Now, like addition, we can also do subtraction like this. We can also do division and multiplication, asterisk. Now, for this to work, both arrays must have compatible shapes. So in this case, both the array have 4 elements. What if I add one more element to my first array? Can we do element-wise addition now? If I ask you to do it, forget about NumPy. If I ask you to do element-wise addition of these two arrays, array 1 and array 2, would you be able to do it? No, you would say they are incompatible. You have 5 elements in array 1 and 4 in array 2. So this operation cannot be done. If you run it, it will give you a value error saying operands could not be broadcast. So they must be compatible in shape. Now let's say you want to perform some operation between an array and a single number. Then what will happen? Let's say plus 5. You might say again they are incompatible. So it will give an error. Let's try. No, it's not giving an error. It's adding 5 to all the elements of my array 1. So what just happened here? Think of it like broadcasting. So NumPy automatically stretches a number to match the array. So this is equivalent to what NumPy does in the background is it converts this 5 into something like this. And now 5 gets added to all the items of this array 1. Why is it giving us error? Okay, there are 5 items in array 1, so we need to add one more. Right? Array 1 have changed if you see here. 1, 2, 3, 4, 5. So I have 5 items. So that is the reason I have to have 5 items in my scale, this array as well. So this is called as broadcasting. And we'll have a separate video in this because this is a more detailed discussion. So we'll have a separate video where we'll discuss more broadcasting in more detail. Now, NumPy also comes with tons of built-in mathematical functions, which you can apply directly. Of course, it's library for speeding up your math operations. It comes with a lot of mathematical functions. Let's try a couple of them. So I have my array 1. Let's say we want to calculate the square root. So we have a function, square root, and we can pass the array 1. Now, you might say, what's the big deal here? I had the math library, which can also calculate the square root. But in the math library, if you use the square root function of the math library for this NumPy array, you have to use a for loop to apply that operation on all the items of your array. But here, no for loop is required. These functions are vectorized. All the functions that are available in NumPy library, they are vectorized, which simply mean that they automatically get applied to each element. So no loop required. No loops required. Why? Because the functions are vectorized, which means they automatically apply to all elements without the need of for loop. Couple other functions. So we have, for exponential, we have exp. We can pass the array 1 here. It will give me the exponential. Then you have log. Let's say we want to calculate the natural log. So for that, we have a function called as np.log. You can pass the array 1. And this is the log to the base 10. And let's try a trigonometric function also. So maybe sine lp.sine array. So these are some of the built-in mathematical functions available in NumPy. There are many more, which we can explore later. NumPy also supports operations like floor division and modulus. So let's try floor division. So this is my array 2. Array 2. And let's just divide it by array 1, but I have to go ahead. Let's create new array here. So this is array 2 and I'll create one more array. And if I do array 2 floor division array 1, this is what I have. Let's try modulus as well. So we have our array 1. Let's divide it with array 2 and look at the remainder. So modulus operator we have. And these are the remainders that we are getting. And yes, that's a quick introduction to mathematical operations in NumPy arrays. In the next video, we'll build further, learn about aggregate functions like sum, mean, max, and more. See you in the next one.